All right, today we're going to talk about right triangle trigonometry and the 6 trig functions of a right triangle. So most importantly, these work only if your triangle is a right triangle. We're going to use this symbol, which is theta, to represent our angle. And with respect to this angle, this side would be our opposite side, this side would be our adjacent, and the side always opposite the right angle is our hypotenuse. So the three main trig functions are sine, cosine, and tangent. And the sine of an angle is always the opposite side over the hypotenuse. Cosine is always adjacent side over hypotenuse. And tangent of the angle is opposite over adjacent. A lot of you learned SOHCAHTOA in an earlier grade. That's fine to use that. That works. And then over here will be our reciprocal functions. So the reciprocal of sine is cosecant, and that is hypotenuse over opposite. The reciprocal function of cosine is secant, so that's hypotenuse over adjacent, and the reciprocal function of tangent is cotangent, which is adjacent over opposite. So example 1, we have a triangle, right triangle. Theta is down here. We have the opposite side here would be 3. The adjacent side here is 4. And before we find all 6 trig functions, we need to find the hypotenuse. So when you're given 2 sides of a right triangle and you need to find a third, you're going to use Pythagorean theorem. So a squared plus b squared equals c squared. Now, it does not matter which sides are a and b. Those are the 2 legs of the right triangle. But the hypotenuse over here, that must be your c. So we've got 3 squared plus 4 squared equals c squared. 9 plus 16 equals c squared. 9 plus 16 is 25 equals c squared. Square root both sides, and we get plus or minus 5, but because we're talking about the length of a side, we are only going to go with that positive answer. So the hypotenuse is 5. So, sine theta. We are down here sitting on this angle. The sine of theta would be opposite over hypotenuse, so 3 over 5. Cosine of theta, again down here, cosine is adjacent over hypotenuse, so 4 over 5. Tangent of theta, tangent is opposite over adjacent, so 3 over 4. And then we're going to look at those reciprocal functions. Reciprocal of sine theta is cosecant theta. So that is hypotenuse over opposite, so 5 over 3. Secant theta is hypotenuse over adjacent. And cotangent theta would be adjacent over opposite. So we have all 6 trig functions and their ratios. On example 2, they tell me that cosecant theta is 3 over 2. Cosecant theta is 3 over 2. So they're telling me the hypotenuse is 3 and the opposite is 2. And then they want me to find all the other trig ratios. So I think best thing to do would be to draw a right triangle. Does not matter where you put your theta. I'm going to put my theta up here. Again, if we look up here, cosecant is hypotenuse over opposite. So this is my hypotenuse. This is my opposite side. So with respect to theta being here, hypotenuse is here, and opposite is down here. Again, I need to find this leg here. So I'm going to use the Pythagorean theorem. say 3 squared plus, we'll call this one b squared, whoops, not b squared, whoops, 2 squared. 2 squared, the leg, 2 squared plus b squared equals 3 squared. So I've got 4 plus b squared equals 9. I'm going to subtract 4 from both sides. Square root, and I get plus or minus 5, but again, because we're talking about a side length, that other leg is radical 5. So I will put radical 5 here. So we know cosecant theta is 3 halves. That's the given. So really, before we did anything, we could find sine, because remember, the reciprocal of cosecant is sine. So the sine of theta would be 2 over 3. Now let's move on to the other two functions. Cosine theta, again, we're up here now. Cosine is adjacent over hypotenuse, radical 5 over 3. Tangent theta, tangent is opposite over adjacent. We don't want to leave a radical in the denominator, so we will rationalize. So tangent will be 2 radical 5 over 5. Now let's look at the reciprocals. Reciprocal of cosine is secant. So the secant theta would be hypotenuse over adjacent. We need to rationalize. So we get 3 radical 5 over 5. And then tangent theta. Tangent would be adjacent over opposite. And so then we have all 6 trig ratios. The last thing we're going to talk about are the special right triangles. So we have a 45, 45, 90 and a 30, 60, 90. And the relationship between the sides on a 45, 45, 90, and you need to memorize these, are the sides opposite the 45 are your 1, and the side opposite the 90 is your radical 2. When we have a 30, 60, 90, the side opposite the 30 is 1, the side opposite 60 is radical 3, and the side opposite the 90-degree angle is 2. So let's look at the sine of 45. Doesn't matter which 45 you want to be sitting at, we'll just pick down here. Excuse me. Sine is opposite over hypotenuse, so 1 over radical 2. We will rationalize. So we get radical 2 over 2. Cosine of 45. Cosine is adjacent over hypotenuse. Again, we'll rationalize. And we get radical 2 over 2. The tangent of 45. Tangent is opposite over adjacent, so 1 over 1 is just 1. So that takes care of the 45. Let's move over to this triangle. Let's look at the sine of 30. So I'm down here, 30 degrees. Sine is opposite over hypotenuse. Cosine 30. Cosine is adjacent over hypotenuse. Tangent of 30 is opposite over adjacent. Again, we'll rationalize. Those are all my 30s. And then I'm left with my sine of 60 degrees. So now we're up here at this angle. Again, sine is opposite over hypotenuse. So sine of 60 is radical 3 over 2. Cosine of 60. Cosine is adjacent over hypotenuse. And tangent of 60, tangent will be opposite over adjacent. So radical 3 over 1, which would just be radical 3. So those are all the trig ratios for the special angles of the 45, 45, 90, and 30, 60 degree triangle. So you'll work now on your homework, and I will see you Monday.